Let's take a look at how to read these things. I have this great big routing table up here. It's a little bit blurry because I blew it up so we could make it really big. I shamelessly stole this thing from a Cisco article, and I've given you the source here. This piece is also stolen from the same article. All right, let's take a look at some of these things. First of all, we have, if we look at the very far left, we have the route source, and you've already seen that. These mean static. The C means directly connected. The R means it came from the RIP routing protocol. We haven't talked about the L yet, and so we'll talk about those as we go along in a few minutes. The next thing we have is the destination network. So in other words, what network? Now notice that the router doesn't really care about IP addresses. It cares about networks. And so this is the network we want to get to. 172.16.1.24 or 1.0/24. So that is, in other words, now this router knows about how to get to that network. Next is the administrative distance. Right here in this case of RIP, it's 120. Remember that it's 0 for directly connected, and it is 1 for a static route. The next number over here is something called the metric. Now, the metric is, according to this routing protocol, what is the best way to get to something? How do I describe that? In the case of RIP, it's the number of hops it's going to take to get to a network. So in other words, this is saying the administrative distance is 120, and I can get to this in one hop. This one's saying 172.16.30 I can get to in 2 hops. So in other words, it's going to take the smallest one. So if these match, in this case I've got, let's say that there was a conflict. I don't have a conflict here, but let's say that we did have a conflict, and we had 2 120s, and one of them was a 2 and one of them was a 1. Well, we're going to take the 1, right? That's the shortest distance. So this metric is the second thing you look at if you have a match up here. Now, it's not always hops. Other routing protocols use other methods too, some calculations that we're not really going to go into in great detail in this course, although you would need to know a lot more about it if you were studying for your CCNA. But things like the speeds of the links and so on would be taken into account in some routing protocols. The next thing is via next hop, and so this is, remember when we typed in a static route, we typed in the next hop, that is to say the interface on the next router that it's going to go to. And then we have a time over here. This is called the timestamp, and the timestamp means this is the last time I heard from this network. So this is the last time that this information was updated. And then finally we have the interface from which it will go. Now this is kind of redundant, because if this is the next interface, then obviously it has to be some specific interface that it leaves to get to that, but we do have both. And there are some types of routes that don't have both, and I'm not going to get into that kind of detail here. We have things like ultimate routes, and I'm not going to get into that. But some route types don't give us both. So we have both of them available to us, so some route types will just give them both to us. So that's all the parts. Now, what about this thing up here? Gateway of last resort is 209.165.200.234 to network 0000. What's that about? Well, we're going to get into the gateway of last resort in another video. I'm going to save that one and talk about it later. So I think I'll just skip over that now, but it is, I will tell you as much as to say this is the same as a default gateway for a PC, for example, or for a switch or whatever. I said I would talk about L's. Yeah, the L right here. This is new as of version iOS 15, if I'm not mistaken. And what it shows here, you'll find something quite interesting if you look very carefully at this. This directly connected network is a /24 network. However, this L, you'll notice, is a /32, and it has a specific address on it. So what in the world is a /32? That means every part of it. Notice that these are not really network masks. They are not subnet masks, so to speak. So a 32 would mean the whole thing. Remember, the 24 means the first 3 octets is set. And after that, anything, right? This 4th octet could be anything, and it would match this. Now, in this case, since it's 32, there are no other alternatives. This entire thing, all 4 octets have to exactly match for a match to take place. So what is this 1.1 address? That is actually the interface address on the router. So this is the router's interface. Let me go back to this guy. Now I've added some other stuff for a later video that I haven't made yet, so ignore these things for now. But look over here, this 192.168.1.1. That would be, it would know that 1.0 is the directly connected network, and the 1.1 would be the L entry in that case, if this were a iOS 15 or above, which it was not in this case. So we didn't see it when we did these routes. All right, that's pretty much it for how you read these things. Just remember, though, that this is not really a subnet mask, because you can't really have a 32 subnet mask. And this does not represent a network. It represents an actual address. And whenever you want to specify an actual address, you would put a /32. All right, that's it for this.